Okay, welcome back. So in the last video we talked about the motion of an object in, uh, in the course of polar coordinates. I took the velocity in polar coordinates and then found the velocity of the final velocity of the object at some time, the maximum height, the range and so on using polar coordinates. So in this video I will be talking about a different approach on projectile motion, which is the variation of the angle. Alright, the variation of the angle. Now I'll generally take plane like this, a horizontal plane, and I'll take an object like this. Right? There is some velocity v here and some theta here. Right? If the object, this is at A, and if the object goes like this up to B here, right? This is at A at t equals 0, and this is t equals t, and this goes to B here, and the maximum height achieved by the object is h, the range of the object is r. Right? We in the previous videos we derived the equations for this. So t equals 2 times v sine theta by g, h equals v squared sine squared theta by 2g, and r equals, right, t equals 2 times v times sine theta by g, h equals v times sine squared theta by 2g, and r is equal to v squared sine times sine 2 theta by g. So those are the three derivations. If the angle between the velocity and the horizontal is theta and the velocity is v, and it is the time taken by the object to complete the motion is t, the maximum height is h, and the range is r. We found those in one of the previous videos. So now I am not going to talk about that. I am going to talk about the velocity of the object at two angles. The same, I am taking the same object, same plane, and the same two dimensions, but I am going to change the value of theta. I am going to project the same object. Now, if it is confusing to you, I am going to project two identical objects that have the same mass, same density, everything, as if it is like a clone, as if it is a carbon copy of that. I am going to take the same two objects, two identical objects, and project it from the same position A here, and I am going to change the value of theta, keeping the velocity of v constant. Value of v will be constant, velocity will be constant, but the angle between velocity and the horizontal direction will be changed. So theta will be changed. So if I draw that in a horizontal plane like this, this is the course, right? Alright, so two objects, so now they will actually overlap each other, so I can't actually draw two objects here. There is a paper and you can draw that. I'll draw only one object. Actually, this is as if the two objects are one behind the other. If you are considering a plane like this, two objects will be like this, right? The two objects will be like this. So if you are viewing from this angle, if you are viewing from this angle or this angle, right? This angle or this angle, you will see only one object. So it's the way it comes here, right? So the object will be like this. So the first angle will be taken as theta 1, and the second angle theta 2. There is somewhat more tilted. Theta 1 is more tilted towards the horizontal, and theta 2 is more tilted towards the vertical. So the object will go like this from here, and the object will go like this. Now possibly when r is equal to v squared sine 2 theta by g, now you know that even if you are keeping v constant and g is a constant for the same place and same thing, g doesn't change for the same place. So V is a constant, so V squared is a constant. So if R equals V squared sine 2 theta by G here, R equals V squared sine 2 theta by G. So V is a constant, so V squared is a constant, G is a constant, so V squared by G is a constant. So R is directly proportional to sine 2 theta. So you know when the theta increases, 2 theta increases. So when 2 theta increases, sine 2 theta increases. So when R is directly proportional to sine 2 theta, when theta increases, you can say that R increases. So when theta 1 is greater than theta 2, theta 1 is greater than theta 2, 2 theta 1 will be greater than 2 theta 2. So 2 theta 1 is directly proportional to R. So R1 will be greater than R2. Right? R1 will be greater than R2. Now, this is, I'll take this one as the mean base. So this is the mean base. Mean base. Right? This is the mean base at which the plane at which we are projecting these two particles, mean base, and I will measure the angle counterclockwise, so anticlockwise from this position. This is 0, so this is 0 degrees. 0 degrees. This is theta 1 in the counterclockwise direction. This is theta 2 in the counterclockwise direction. Theta 2 is greater than theta 1. So if we increase the angle, so this is 0 degrees, you can increase the angle up to 180 degrees. So you can change from here up to here. Right? So 180 degrees. So the angle variation of theta will be from 0 to 180 degrees. So you know that R1 increases, the range of the function increases when you increase the angle. So what is the maximum range of the function? So you know that when the angle is increased, R1 is equal to R2. So sometimes you may say the maximum angle is 180 degrees. Right? The maximum angle is 180 degrees. So the maximum range should be at 180 degrees. So if the angle is 180 degrees, it will be horizontal and it will move in this direction. Right? There will not be a projectile motion, there will be only a horizontal motion, but that doesn't matter. Horizontal motion is a derivative. Horizontal motion is a derivation of the projectile motion in which the angle is 0, 180. So you say that since the angle is increasing, when the angle is increasing, R is increasing, the maximum angle that can be achieved is 180 degrees. So the maximum range is 180 degrees. Now this isn't true because the angle is not directly proportional to theta. I took the assumption that when theta increases, 2 theta increases. When 2 theta increases, sine 2 theta increases, because sine is a trigonometric function. Now if you are not well versed with the sine functions, I invite you to watch my trigonometric videos first and come back here if you have some doubt on the trigonometric functions, the graphs of those, because it will be vital here. So when 2 theta increases, sine 2 theta increases, because sine is a function, trigonometric function, in which when the angle increases, the function also increases. So when the angle increases, sine function increases, cos functions decrease, and tan functions increase. So sine functions increases. So when the angle increases, so when 2 theta increases, sine 2 theta increases. But sine 2 theta, unlike tan 2 theta or any other thing, sine 2 theta and cos 2 theta have maximum value. Now, tan 2 theta, the maximum value of a tan function is positive infinity and the minimum value is negative infinity. But for sine and cos, the maximum value will be plus 1 and the minimum value will be minus 1. So there must be an angle at which sine is equal to plus 1. So sine 180 is equal to 0 as well as sine 0 is 0. So if the angle is when the angle is 0, the sine value is 0. So sine 0 R is equal like that. So what happens is that when this angle is 180 also, it will be 0. So what actually happens is that if you draw the sine graph, the variation of sine theta, right, variation of sine theta with theta between 0 and 360, so this is 0, this is 90, this is 180, this is 270, and this is 360. The graph will look like the maximum value is 1, that is achieved at 90 degrees. Right? At 180 it will be 0, at 270 it will be minus 1, which is the minimum value. And at 360 it will be again 0. So the graph will be simply like this. So we also call it a sinusoidal graph. Right? It has actually a smooth curve, right? Like this, a smooth curve. Right? This is called a sinusoidal curve. Theta and theta, right? Sin theta versus sin theta, the graph will be like that. So the maximum value is 0, and at now we are also considering between 0 and 180, because this is a plane we can go beyond 0, beyond 180, and we can go beyond 0 also, right? This, so between 0 and 180 only we are taking, between 0 and 180. So in this graph, at 0, sin theta is 0, and again at 180, sin 180 is 0. So we are taking only this part. So the corresponding part on the graph will be this part. Right? This part. That is color. Right? The area that is under that colored part will be the corresponding part on the graph. So there is a maximum value that the angle can take, but at 0 it is 0, and 180 it is 0. 180 also is 0. So it is not at 180 that we find the maximum value for r. To find the maximum value for r, we are saying if we take r equals v square sine 2 theta by g, r max is v square by g is a constant, so it will not change, it will not affect the value of r. So r max is when sine 2 theta is maximum. So sine 2 theta maximum, sine 2 theta over sine any angle maximum is 1, so the r maximum is v squared by g, and r minimum is minus v squared by g, right? But minus v squared by g cannot be found because the displacement in practical situations, right? In this type of motion, because we are considering a horizontal plane, we can't dig it down the plane or we can go up the plane like that. So only the maximum value of r can be found. R max equals v squared by g, but that is at sine 2 theta equals 1. So considering between 0 and 180, there is only one angle that satisfies this equation, sine 2 theta equals 1. So sine 2 theta is 1 only when sine 2 theta is equal to sine 90. Right? Sine 2 theta is 1 only when sine 2 theta is sine 90. So if sine 2 theta equals sine 90 between 0 and 180, you know that 2 theta equals 90. So theta equals 45, or 5 by 4. 45 degrees, which is easy. Right? Theta equals 5 by 4 or 45. Right? So you know, to achieve the maximum height, you have to project this projectile in a direction that is 45 degrees, that is 45 degrees angle to the horizontal, or if 45 is actually between halfway or the midway between 0 and 90, so 45 degrees will be the same at this one, at what you call the 45 degrees to the horizontal will be the same as 45 degrees to the vertical. Now you will say, now if you are considering 0 and 180, we have only, we can now, if you consider, if you are going to split this part into two parts here like this, and consider the first part between 0 and 90, this is 90 degrees, right? This is 90 degrees, the vertical line, this is horizontal, so the first part will be this part, and the second part will be between 90 and 180. So if we are having one velocity, say theta 1 in the first part and theta 2 in the second part, so can we achieve the maximum displacement only when theta equals 45? Can't we achieve a maximum displacement when theta is between 90 and 180? So it will be possible. But the only thing is now you have to measure the angle in the counterclockwise direction. From this, taking this one, this is counterclockwise. So in the clockwise direction, in this direction, this should be 45. Similarly, actually, what you know is you have taken mirror effect. You have just flip it over. You have taken the mirror effect of this, and this will be 45. If this is 45, this is 45. So this is also 45 because this is 90. This is 45. Then it will have the same direction, same maximum displacement in that direction. Same maximum displacement in that direction. So if this is 45, this angle is 135. So at two angles between 0 and 180, you can find the value of the maximum value of R. So that is sine 2d equals 90, sine 2d equals sine 90. So 2d equals 90 degrees, θ equals 45 degrees. If you are taking between 0 and 90, and you can also find θ equals 135 degrees if you are finding between 90 and 180 degrees. So in this video, I explained how to find the maximum value of a certain projectile motion using the general equations of motion and the derivatives we have found. So in the next video, we will find how to change the height of the in this video, we talked about the variation of the angle of theta. In the next video, we will find the variation of height h. So see you then.